We are doing box plots.
So to review this, box plots, right? Box plots are also called box and whiskers 5-number summaries. Right? They're awesome because you get to see all this data. Just by looking at a box plot, you can identify the minimum. You can identify the maximum, the median, the lower quartile, and the upper quartile, right? You can easily see all this. That's a pro. That's one of the good things about a box plot. One of the downfalls, one of the cons about box plots is that it's a quartile, right? Quart means 4, 25%. These are all supposed to be even. They're all 25% of the data. But do they look like they're 25%? Do they look even?
Not at all.
Not at all, right? So when you have data that's really spread out, a box plot doesn't do a good job visually of showing that, right? In fact, if you looked at this data, 4, 5, 7, 7, 7, 8, 9, 9, it's hard to tell that there are 2 9s, and it's hard to tell that there are 3 7s, right? So it doesn't really show you a whole lot about what the data inside the data looks like. It tells you these 5 pieces really well, but it's hard to get an overall view of everything about the data. So then we go down to histogram, right? In histograms, the really good thing about histograms is that the x-axis can be a range, right? Meaning I can show like 100 pieces of data in a pretty small graph because I can have a range down here as opposed to showing 1, 2, 3 all the way to 100. I can have a range. So that's what's really good about histograms. You can take a large amount of data and put it into one graph. The downfall is if I decide to do 0 to 3, 4 to 7, 8 to 11, but somebody else decides to do 0 to 2, 3 to 5, 6 to 8, 9 to 11, our graphs are going to look different. So the downfall of histograms is that some people are going to pick different ranges, and it's hard to compare them even if they have the same data. The last type of graph we're going to talk about today are dot plots. And there are a couple types of dot plots, or maybe they're not necessarily dot plots, but they're very similar, so I consider them the same. In dot plots, you've already done dot plots in your life. Many of you already know them by the name of frequency tables. Or even, I consider dot plots to be stem and leaves. That's a type of dot plot to me. It shows individual pieces of data in units. So if we're still working with that same set of data, 4, 5, 7, 7, 7, 8, 9, 9, a frequency table starts with a number line. 4, 5, 6, 7, 8, 9, right? A number line has to have every single digit. You can't skip a digit in the number line. But then the frequency table takes us, and we say there's 1 4, so I'm going to put, I put an X, you could put a dot. There's 1 5. There are 0 6s. There are 3 7s. There's 1 8. And there are 2 9s. A dot plot is awesome because, and I'm going to put this at the very bottom, you can easily see outliers. Dot plots are great. That's why a dot plot's fantastic. I can easily visualize what numbers don't belong. Looking at that frequency table that we just made, looking at that dot plot we just made, what are my outliers? What don't belong? You've been doing this since kindergarten, right? The teacher shows you 4 pictures and says, what thing doesn't belong? What doesn't match? Right? Sesame Street trained you well for this. Yeah. Well, that's our highest level, right?
Yeah.
So if I'm looking, where's the natural break? Where does the data group around? The data groups around the 7s, right? So anything pretty close to 7, I would say is good. All right, so if I went 1 away, that 8 I would think is okay. 2 away, that 9, that 5 is fine. But this 4 is 3 away. You could even make the argument that the 4 and the 5 don't belong together. They don't belong. Most of the data is up here. So we can easily identify these 2 numbers are separate from the group. There are outliers. Now there's a better mathematical definition with outlier. You take a certain percentage of the median and plus or minus that many numbers. We're not getting into that yet. We're just going visually. These don't belong. Let's talk a little bit more. Yep.
Wouldn't the downside of a dot plot be if it had a huge outlier as in it went 1, 2, 3, 4, 5, 6, 50.
Yeah. It was way.
You'd have to write all the way.
You'd have to make the whole number line, right? So if it was 1, 2, 3, 4, 5, 6, 50, you'd have to make a number line from 1 to 50, right? And that would be a downfall of a dot plot. Stem and leaf. Leave some space right here, guys, because we're going to add something to it, okay? Stem and leaf. If I was going to do girls' ages, right? And my data was, there's a 12-year-old, a 13-year-old, a 13-year-old, a 20-year-old, and a 30-year-old. A stem and leaf is when you look at all of the data and say, huh, they're all 2-digit numbers, right? So my first stem is going to be a 1. So I'm going to put 1, 2. That means that there's a 12-year-old. The next piece of data is a 13-year-old. So I'm going to put the 1's already there. I'm going to put a 3 because that means 13. There's another 13-year-old. So the 1's already there. I'm going to put another 3 because that tells me there's a 12-year-old, a 13-year-old, and a 13-year-old. Then I go to 20. My 10's digit changed. So I'm going to change down here. And there's a 20-year-old. And then last, there's a 30-year-old. The important part of a stem and leaf is that you should always make a key. You should identify that this means 12. Because sometimes, if it was 1.2, you could put the 1 here and the 2 here, and it would mean 1.2. Instead, this one, it means 12. Have you seen stem and leaves before?
Yeah.
You can also make what are called double stem and leaves, back to back. So if my data for boys was 13, 15, 21, I can, on this same stem and leaf, just work backwards. 13, 15, and 21. This is what you're going to do for your homework tonight. And if you were looking at this data, could you identify the outlier? What doesn't fit? What's all by itself?
The 30-year-old.
The 30-year-old. I mean, we could even question these 20-year-olds in here, right? Right, so the great thing is with dot plots is that you can easily see the outliers. The bad news with dot plots is if you have a huge amount of data, you're going to be making a lot of work for yourself.
So,
Yeah?
I don't get why do all that.
It's just another way of organizing the data to visually see it. Instead of just having a big list of numbers, you can organize it in a dot plot, or you can organize it in a histogram, or you can organize it in a box and whiskers, because as humans, we're much more visual as opposed to giving me a list of 50 numbers and saying, what do you think about this? So there are pros and cons to all three different displays.